Hey class, it's Mr. Zimmerman, and today we're going to look at the review guide. We're going to continue to convert between logarithmic equations and convert them into exponential equations. Last time we did the opposite. We took an exponential equation and basically we took it here. So if you want to reference this, this is number 2. We're currently going to go turn logarithmic equations and turn them into exponentials. So let's dive in. So I'm going to go ahead and just reference this equation. I know that b is always going to be risen to the x, where y. The reason I remember this is b represents the base, x is the exponential. There's an x in the exponent. That's how I remember what the definition is. And it also signifies that x has to be in the exponent. It leaves it equaling a number, which is going to be y in log form. That means within parentheses is the y value equals the x. So let's just kind of convert some things. My base is 3 to the number on the outside is 8 is 14. I'm going to do it again for the next one. Even though it's a fraction, it doesn't necessarily matter. 5 to the ninths. Now I'm going to draw parentheses around this to signify that I'm going to include both the numerator and the denominator with the exponent. Okay, the exponent is 4, which is equal to x. Next up, log of x equals 4, but there's no number. Where's my number here? Now, from experience, this is just mathematicians being lazy. When there's no number written, we have to assume it's the log of 10, and this is due to a lot of astrophysics using repeated units of 10. So like the log of 10 is used to basically determine how many numbers are in a number, and for a number like 4, it's like, bro, there's one digit. For the number 100, there's 3 digits. But when you're examining a black hole that's like 3 trillion away, a log of 10 is just a quick way to assess how many digits. And then we can use that instead of actually counting it. But the anecdote aside, let's go ahead and continue. The log 10x equals 4. Bada bing, bada boom. Let's switch it. The base is 10. It's equal to the fourth. It's equal to x. And let's go ahead and examine this next one. ln is 6. ln is supposed to be read as the natural log. And that basically means this is log with the base e to 6 equals 15. This is shorthand for what this represents. Now I'm going to go ahead and convert forms. My base raised is equal to 6. Now I do want to point out one quick thing before we conclude this video. This was a quick review on how to convert between forms. Remember, read it. Read the log to the base, to the base, to the base, to the base. And that's going to get you started on your journey. And then you might notice how I always go here, raise it to the exponent, raise it to the exponent. So that's where my mind goes. And then finally, you jump back to the 14, jump back to the x. In these conversions, I would definitely say that this conversion is one of the more usefuls in addition to this guy. The reason being is that they provide you with a way to calculate x. On the top, I could not calculate x, but here I can. Likewise, I have no idea how to solve that equation. Here, I can use a calculator to do it. So I hope this was a quick guide. This is just a review. Make sure that if you need extra practice at this point and you identify that you go to Canvas and check that section out. Literally, it's called extra practice. This is it for now. Good job.